Stars and constellations. Our universe is so large that to measure the distances between its constituent objects, the unit kilometer would be extremely small and inconvenient. Hence, two new units have been defined. The first one is called as a light year. 1 light year is the distance traveled by light in 1 year. The speed of light is 3 into 10 to the power 8 meter per second. The distance covered by light in 1 year is 1 light year is equal to 3 into 10 to the power 8 meter per second multiplied by 365 days multiplied by 24 hours multiplied by 60 minutes multiplied by 60 seconds equal to 9.46 into 10 to the power 15 meter is equal to 9.46 into 10 to the power 12 kilometer. Thus, 1 light year is equal to 9.46 into 10 to the power 12 kilometer. When we say that our nearest star called Alpha Centauri is 4.3 light years away from Earth, it is at an actual distance of 4.3 light years equal to 9.46 into 10 to the power 12 into 4.3 equal to 40.67 into 10 to the power 12 kilometer. Our Sun is 150 million kilometers away from the Earth. That is, it is only 8 light minutes away from Earth. To repeat, it takes light only 8 minutes to traverse the Sun-Earth distance. Another unit of distance is called parsec. 1 parsec is equal to 3.26 light years. 1 parsec is equal to 30.8396 into 10 to the power 12 kilometer. Our solar system with our Sun, Earth and other planets belongs to the Milky Way galaxy. A galaxy is a collection of stars. Milky Way galaxy is spiral in shape and has a diameter of 100,000 light years. Our sister galaxy, Andromeda, is also a spiral galaxy. Andromeda is 2.5 million light years away from Earth. That means it is really extremely far away. The Andromeda galaxy is the most distant object you can see with your naked eyes. When you look up at the night sky with your eyes and not with telescopes or binoculars, you will see stars from our very own galaxy. Each star is like our Sun, emitting light, some bright and some not so bright. And because they are so far away, they look like pinpoints of light. But Sun is the nearest and brightest star for Earth. That is why during daytime, you do not see any stars in the sky, although they are present. During a solar eclipse, when the moon hides the bright sun and the sky darkens for a while, we do see some stars in the sky even during daytime. We see a large number of stars on a clear dark night, and many of these stars, taken in a group, have a peculiar shape or pattern. And since they are far away, these patterns remain constant even as the Earth revolves around the Sun. Since the ancient times, human beings have the habit of naming these shapes. Different names were given to these shapes by different cultures. Groups and forms of stars having recognizable shapes and patterns are called constellations. Generally, these shapes are of human beings or of animals. About 88 such constellations are known to us. Sanskrit name for constellation is nakshatra. Of the 88 constellations, 32 can be seen from the northern hemisphere during various seasons, and 56 can be seen from the southern hemisphere during various seasons, as the Earth revolves around the Sun in a year. Remember that each star in a constellation is actually extremely far from each other, but from the Earth's observation point, they appear to be in close conjunction, but actually they are not. Some of the important constellations that are visible in the northern hemisphere are Ursa Major, Saptarshi, Orion, Mriga, Scorpio, Vrishchika, Pleiades, Kritika, Cassiopeia, Sharmishta. Ursa Major is also called the Great Bear constellation. Its Indian name is Saptarshi. It looks like a large question mark or a kite with a tail. Sometimes it is called the Big Dipper also. The constellation consists of 7 bright stars. This constellation can be seen clearly in all season in the northern hemisphere. Orion is the hunter constellation. Its Indian name is Mriga. The arrangement is supposed to be resembling a hunting man. The 7 stars that are seen form the body of the hunter. From Indian mythology, the 4 stars in the corner resemble 4 feet of a mriga, deer. The 3 stars at the center are very prominent, known as the hunter's belt. It is seen in the northern hemisphere in winter months. Scorpio's Indian name is Vrishchika, Bichu. The arrangement of stars resembles a scorpion with a tail and pincers. The Indian name of Pleiades is Kritika. It does not have a particular arrangement, but looks like a cluster of twinkling stars. It is quite visible in the northern hemisphere during all months. Cassiopeia or Sharmishta is a W-shaped constellation, quite visible in the northern hemisphere during all months. Why do we see different constellations during the year? If observed through the year, most of the constellations, those that are not close to the pole star, shift gradually to the west. We will discuss about the pole star in the next screen. The apparent movement of the constellation is caused by Earth's orbit around our Sun. In the summer, viewers are looking in a different direction in space at night than they are during the winter. You will find very many monthly constellations maps on the internet put out by stargazing enthusiasts and various planetariums. Now, let us discuss about the pole star. When you observe the sun in the morning, it rises in the east and sets in the west in the evening. As the day goes on, the sun moves through the sky, east to west. When you observe a star or a constellation at night, they also rise in the east and set in the west as the night wears on. As the night goes on, the stars and the constellation move through the sky east to west. Why so? The reason for this is that the Earth spins on its axis once in 24 hours, west to east. That is why everything in the sky looks to move east to west. It is relative or apparent motion for us, the observers on the Earth. The Earth's rotational axis is tilted by 23.5 degrees to the Sun-Earth plane. In the northern hemisphere, it points towards a star above, known as the pole star or the North Star. The axis points towards the Southern Cross constellation in the southern hemisphere. The closest star in line with the South Pole is the Sigma Octantis. In the night sky, in the northern hemisphere, all stars appear to revolve around the pole star. The pole star is an exceedingly small and faint star. To locate it, you must first locate the Ursa Major or the Big Dipper constellation. See the first 2 stars in the constellation of 7 stars. Draw a straight line from these 2 towards the north. The first visible star that crosses this line is the pole star. We should end our discussions on stars and constellations by answering a few of Paheli's and Bujo's questions. If light from stars takes years to reach us, are we looking into the past when we look at the stars? Yes, we are. Why we do not see the stars during the day? Why are they visible only at night? Sun is the nearest and brightest star for Earth. That is why, during daytime, you do not see any stars in the sky, although they are present. During a solar eclipse, when the moon hides the bright sun and the sky darkens for a while, we do see some stars in the sky, even during daytime. Why does the sun appear to rise in the east and set in the west? The Earth spins on its axis once in 24 hours, west to east. That is why everything in the sky looks to move east to west. It is relative or apparent motion for us, the observers on the Earth. Paheli's grandfather told her that there is one star in the sky which does not move at all. How is it possible? In the northern hemisphere, it appears as though the pole star does not move at all. This is because the Earth's axis is pointing towards it. Bujo wants to know if we can locate the pole star with the help of Ursa Major. Yes, we can do that. The pole star is an exceedingly small and faint star. To locate it, you must first locate the Ursa Major, or the Big Dipper constellation. See the first two stars in the constellation of 7 stars. Draw a straight line from these two towards the north. The first visible star that crosses this line is the pole star.